Hello. This video is intended to show how I have met one of the requirements for the NMRA Achievement Program's certificate for Model Railroad Engineer Civil. The requirements for any of the Achievement Program certificates may be found at the NMRA's website, www.nmra.org. Once there, pull down the tab for Education and select Achievement Program, and then you can see the different categories. Among the numerous requirements is the construction for merit judging of at least 3 items of scratch-built track models from a list of 15 possible options. The items may or may not be included on your layout, but fortunately there is provision to accomplish one or more of them elsewhere, such as on a different layout or even on a project board, as I've opted to do here. In this video, I will illustrate how I completed a scratch-built turnout for merit judging. This is probably the simplest option from the list of 15 possibilities on the list. The turnout can be built in any scale as long as it meets the specific requirements for merit judging. So let's take a look at those now. So to qualify for the Engineering Civil Certificate, the scratch-built models of track work must earn merit awards. Now, most of the merit awards, you have to earn a particular score, but in this case, it's a lot simpler. There are 3 pass or fail criteria. The first is that a self-powered locomotive must successfully traverse all routes through the track work. The second is that the track work must meet NMRA track standards using an appropriate track gauge, such as the NMRA track gauge. And thirdly, the frog and point rails must be scratch-built. You cannot use commercial frogs. However, you can use commercial individual rail to build your own frogs. So those are the 3 criteria, and it's either pass or fail. And if you pass all of them, then you earn your merit award. Now, the guidelines for constructing the scratch-build track work permit the use of assembly jigs, such as those made and sold by Fast Tracks, and you can see those at their website. However, I elected to attempt building my turnout without the use of an assembly jig. Instead, I used a paper template, and that was drafted by my friend Philippe, which was glued to a piece of plywood using 3M Super 77 spray adhesive. Philippe's template provides the length for each tie, and it indicates where the gaps on the PC ties need to be located. I'm building a number 6 right-hand turnout with non-hinged point rails. Now, you can find track templates online. They're pretty easy to locate if this is the route you would like to go. The copper-clad PC board ties were sourced from Fast Tracks, and they offer them in several varieties. I used pre-gap ties and longer ties, which required that the gap has to be filed into them, and you'll need some of those if you're doing a turnout. The ties were cut and filed to length, and then they were sanded on the sides to remove fuzz, and then they were filed on top to clean them in preparation for soldering. These ties were then glued down in place on the paper template with AC adhesive. The point rails were formed using the point form tool, which is made and sold by Fast Tracks. It's basically a filing jig. The Microengineering Code 55 rail is inserted into that tool, and then it's secured in place with an Allen key to tighten up those 2 nuts that you see there. A mill-basher file is used to shape the point rails while it's held in the tool. And then after releasing the point rails from the tool, they can be cleaned up with smaller files to remove any burrs. The flat side of the point rails must be able to nest tightly against the stock rails in the finished turnout. We use the same tool to file the frog rails, and the procedure is the same as it is for the point rails. And the use of tools like this is permitted when you're scratch building your track for the merit judging. This photograph shows 3 pairs of finished point rails and 3 pairs of frog rails. And these are going to be used for my scratch-built turnout and also for a scratch-built crossover that I am building at the same time. And I'll cover that one in a different video. Now, those pairs of frog rails must be soldered together. So I placed them on a piece of wood, nice flat surface, and then I weighted them down with that point form tool. Those tools are quite heavy, and they make excellent weights during construction of track. I then joined the 2 rails with solder. And the top of the rails at the joint need to be filed flat, and that's done with a small flat file, and Fast Tracks sells that file. And here we see 3 pairs of frog rails assembled for use in the scratch-built turnout and also in the scratch-built crossover. The stock rails were formed using another Fast Tracks filing jig tool, and that one is called the stock aid. Now what we're doing here is we're filing notches in the stock rails so that the point rails can nest tightly against them. So again, the microengineering code 55 rail is inserted into the tool and it's secured in place, and then we use the mill file to notch the stock rails while they're held in the tool. And then after releasing the stock rails from the tool, the notches can be cleaned up with smaller files, again to remove any burrs. Those notches must be able to receive the point rails in the finished turnout. And again, we're allowed to use these tools when we're constructing track for merit judging. This photograph shows a stock rail in the stock aid filing jig, along with the large and small files that are used to create the notch. Now the area on the length of rail to be notched has been marked with a red Sharpie, so we know exactly where we need to file. Those files are sold by Fast Tracks. This photograph shows 3 pairs of finished stock rails, and again those are going to be used for my turnout and for a scratch-built crossover. The next components to be fabricated are the guardrails. These are the small rails adjacent to the frog, which help to keep wheels in the right location as they go through the turnout. One end of the rails was inserted into the point form to make the first bend, and then the same with the other end. So you simply stick the rail in the end of the tool there, and you give it a little tweak to bend that rail, and then do the same at the other end. The finished guardrails were compared against the paper templates for correct length and the correct angles. I made several of these, and then I simply chose the best ones to use. And here we see 4 pairs of finished guardrails for use in the turnout and the crossover. The last components to be prepared are the wood ties, and these I also sourced from Fast Tracks, and there are different companies that sell these. The ties need to be cut to length, and then they need to be sanded on all sides to remove any fuzz. I used my Northwest Shortline chopper to cut the wood ties to length. I cut them in batches to save time, and then sorted them out later. The turnout requires 17 lengths of ties ranging from 8 feet up to 16 feet. So I dressed those ties on each end using my Northwest Shortline True Sander, and then I cleaned up on each side using sandpaper. The finished ties were then stored in a plastic container with compartments to organize them by the different lengths. I cut enough ties for 4 turnouts so that I would have enough for my turnout and crossover, as well as a few spares. So this completes the preparation of all components for the turnout, and we can now begin with assembly. So we now move on to actual assembly of the turnout, and we're going to start with a straight stock rail that is lined up in place on the template, and it's held down using the point form tool as a weight. And a steel straight edge comes in handy. That could be placed against the stock rail to help ensure that it's going to be straight. The rail is then soldered to the PC board ties, 1 tie at a time. And I started with the central tie marked S, and then I worked outwards in each direction. Fast Tracks sells suitable flux and solder for this type of work, as well as a complete range of soldering supplies for what we term to be mechanical soldering. That is, you're joining one component to another, in this case rail to ties. I'm using a small file to push down on the rail and hold it in place firmly on the ties as I apply the solder. After soldering the joints on the outside, the steel rule is swapped to the outside, and then the inside joints are soldered. Some of the ties should not receive solder on the inside, so you have to be careful to know which ones those are. This photograph shows the turnout after installation of the straight stock rail. And then the next step is the installation of the curved stock rail. That is the curve is formed with fingers, just gradually getting a bend into the rail, so you do want to pre-bend it. Again, the stock rail is lined up in place on the template and it's held down using the point form tool as a weight. We then solder the rail to the ties one tie at a time, again starting with that central tie marked S and working back towards the throw bar. I am taking care to ensure that the rail follows the curve indicated on the template. At this point, we can't use track gauges. That'll come later. As the curved stock rail reaches the throw bar and the head block ties, it is now necessary to ensure that the rails engage with the straight stock rail opposite. So as those rails come together at the throw bar, that's the time when we can start to use our gauges. So this is a 3-point gauge. It's made by Trifecta, and those are available from Fast Tracks. Here is my scratch-built turnout. I thought I would pause at this point and just review the work that's been done to date. So I began by gluing this paper template to a wood block for a firm working surface. I cut, gapped, and installed the various PC board ties in the correct locations on the template. Those were glued down in place with AC. I then fabricated the various rail components, the 2 stock rails, which have been notched back here for the point rails, the frog rails, which have been angled and then soldered together, a pair of guard rails, and then the point rails, which have been filed at this end. I then have started with assembly, beginning with the straight stock rail. This was soldered in place, starting at the tie marked S, which is here, and working outward in each direction with a steel rule on the inside to keep it straight, and then soldering the joints on the outside. I then moved the steel rail to the outside and soldered the inside joints, but there are a few that do not get solder, and this is to avoid any clearance issues between the guardrail and also between the point rails back here. So those have been marked with an X to remind me that I should not apply solder in that location. We then moved to installation of the curved stock rail, making sure that I'm following the curve on the template. Again, we started at the tie marked S, and I worked my way back toward the throw bar and the head block ties. This part of the curved stock rail has been left loose for now. That is because at a later date, the frog rail will get installed here, and then I'll need to gauge this rail to make sure that it stays in gauge with the frog rail. So we're going to leave this loose for now. Back here where the stock rail straightens out, we need to make sure it's engaged with the straight stock rail. So I've got a rail gauge there to make sure that that is engaged. The next step will be to install the point rails, which go here. Then the frog will come in there, and then the guard rails, and then this will get finalized here. And at that point, the assembly will be largely finished. So we're now going to move on with installation of the point rails. The point rails are next, and again, one of them has a curve in it, so we want to form that curve gently with our fingers before installing the rail. And the wing rails have to be bent to the desired angle, and then they need a little chamfer filed on the inside edge at the end. That's to make sure that the wheels go in there and track properly. The point rails were soldered into place, commencing at the S-tie and working outwards from there. And again, there are several locations where solder must not be applied, and that's where those point rails have to move back and forth. And again, you can see I'm using a track gauge to monitor the gauge as we go along. In this case, we are gauging the straight point rail to the straight stock rail. The frog rails were soldered into place, and the NMRA gauge is now used to verify correct clearance in the various flangeways. And a truck from a freight car was used to verify smooth operation. The point rails were followed by the guard rails, and once again the NMRA gauge was used to verify clearance in the flangeways. I have a track inspection car made by Aztec, and I used that to verify smooth operation through both the straight and diverging routes of the turnout. I've done some more work on the turnout, and I think this is a good time to pause and review some of the work that's been done since the last video installment. I've installed the point rails, which were tapered to mesh up against the stock rails. They were also curved. And then at the far end, the wing rails have been bent, and they've also been chamfered or notched on the end to allow equipment to enter the frog unimpeded. The next step was to install the frog rails. Now this is one of the more critical pieces to install. If they are too far this way, we can have problems with equipment traversing through the frog. And if they are too far out, we can experience what's known as wheel drop, where the wheel falls down into the opening there in the frog. So it's a question of adjusting until we get that just right. We also check the flangeways, and that's done using these little nubs on the bottom here. And we want to check the flangeways right there to make sure that that's good. And then we want to make sure that equipment will traverse through the frog smoothly. So I'm going to put a car on the track, and I want to check to make sure it runs smoothly through there, which it does. And then we also want to check the diverging route. Oops. And that is very smooth. I'm very happy with that. So the next step, I also installed the guardrails, these two little rails here, and those were bent to shape. And again, we use the flangeways tool to ensure that they're in the right location. The next step will be to install the throw bar and attach the switch points to it, drill the hole for the throw wire. I also need to reinforce the frog points. It is not possible to solder that to the top of a tie from above. The turnout has to be flipped upside down, and that needs to be done from the underside. So I've got to get that done. The turnout will then be cleaned up with a wire brush, and I also have to cut some gaps to isolate the frog. And then finally we'll install the wood ties, at which point the turnout will be complete and ready for installation. Now the throw bar is prepared with gaps and also a pilot hole for the throw wire. And once that's done, the point rails can be soldered into place on the throw bar. The spacing between the point rails is critical, and we do have an indication on the NMRA track gauge to help with that. I also installed a second PC tie at the start of the turnout to reinforce the gauge there, as I was having a little difficulty with the rails maintaining gauge at that end. There's just a little too much tension in the rails at that point. At this point, the soldering work is largely finished, and the turnout can be cleaned up with a stiff wire brush. This will remove any acid flux residue, and it also smooths out the solder joints. At this stage, I removed the turnout from the paper template and support boards so that I could reinforce the frog point from underneath, and also so I could cut the isolation gaps for the frog. And you can see that I've marked those with a red Sharpie where they need to be cut. They're in between two pairs of PC board ties. So here the turnout's upside down, and I am reinforcing that frog point from underneath. That's not possible to do it from the top side. To cut those isolation gaps, we have to get a saw blade inside the turnout. So it's necessary to use a saw with a detachable blade. And here you see me doing that. I've created an improvised vise made from two angle blocks with a clamp, and I'm holding the turnout on edge so that I can cut down through the rails with that saw. So the blade can be undone at one end, fed through the turnout, done back up again, and then you can start to saw away. And that particular saw is also sold by Fast Tracks. They're also available in hobby shops. This overhead view shows the isolation gaps after they've been cut on either side of the frog. So that frog assembly in the middle of the turnout is now isolated electrically. The PC ties are about 1/10 thou thinner than the wood ties that I'll be installing, so I added shims underneath the ties. Those were cut from 10 by 60 thou strip styrene, and the PC ties are about 60 thou in width, so this is a pretty good match. These were attached with AC adhesive. The styrene shims were cut long and glued in place, and then I trimmed them afterwards. And here I am trimming the ends of the styrene shims. I'm using a number 17 blade and just basically chopping down at the ends. This photograph shows the styrene shims after installation and trimming. Note that I did not install a shim underneath the throw bar. We don't want to impede its motion back and forth. Okay, another pause to review the work done since the last video segment. I prepared the throw bar with isolation gaps and a pilot hole for the throw wire. I then soldered the point rails to the throw bar. Now this gap between the points is quite important to get right. There needs to be enough passage when it's thrown either way for the wheel to pass on the other side. So the recommendation from Fast Tracks is to protect this stock rail with a piece of paper so that you don't accidentally solder the rail to the stock rail, the point rail to the stock rail. And then when we do the other one, we slip a PC board tie in here to create the correct gap. Now these attachment points here of the point rail to the throw bar are quite important. They need to be fairly strong because there is a little bit of pressure on those with this being thrown back and forth. So you want a really nice solder joint here. And what I was trying to do is create a nice little fillet down onto the tie that really locks that on. We can only solder this from one direction because the other side has to mate flush against the stock rail on either side so that the wheels will pass through smoothly. Once that's been done, we then use this file here, which is available from Fast Tracks, and that's used to smooth out the place where the point rail blends in with the stock rail. And that's done just by filing on the inside. And as we do that, we want to also just roll over onto the top of the rail a little bit, just to create a nice transition point as equipment goes through there. And of course, we want to test it with a truck or a car as well. Something else I did was I discovered that my frog point here was just a little high in comparison to everything else. So I filed that down, and now equipment is sailing through here really nice and smoothly. You can test it with a truck or with a car. It's a little easier with a truck until we're connecting tracks are attached. But this is very smooth going through there. And also check the diverging route. So that's really smooth, there's no hiccup at all. I then removed the turnout from the template because we're done with the soldering, except for this little place under here. This is the frog point, and we were unable to solder it directly to this tie from above, so that's been done underneath. Just reinforce that joint. This is so that the frog point doesn't actually lift and create a problem with a height differential. So with that being done, the next step was to clean the turnout, and that's done with a wire brush. This is to remove any residue from the acid flux that we've been using for the mechanical soldering, and also just smooths out some of the solder joints a little bit. So we do that. The last step in this segment is to cut these isolation gaps for the frog. This needs to change polarity depending on which way the turnout's thrown. So we need to cut gaps through the rails here and through the rails here. You can see there's a PC board tie on either side to give us structural rigidity as we do that. And these gaps are going to isolate this frog so that it's separate from electrically from the rest of the turnout. So to get in there and do that, we use this saw here. And this has the advantage of the blade being detachable from the frame so that we can slide it in there and then hook it back up, stretch it tight, and then cut through those sections of rail. The other advantage is that this blade is very, very narrow. So we get a gap that is very narrow and hardly perceptible in the grand scheme of things. Once those gaps have been cut, I then use the wire brush to make sure there's no little burrs that could potentially arc or connect through there. We want a nice clean gap and should be almost able to pass a knife blade through there, but not quite. So that's most of the assembly done. So the next step is going to be to attach the wood ties. Now these PC board ties are not quite as tall as the wood ties. They're about 10 thou shy. So what I'm going to do is I'm going to laminate 10 thou styrene onto the bottom of these PC board ties, and that'll make them the same height as the wood ties. And then once that's done, I'm going to get all the wood ties on, and then we'll have a complete turnout. So time to prepare the wood ties. So I glued a new template down onto the project board, and the wood ties were glued in place. I used Evergreen Premium White Wood Glue for this, and the template lists the tie lengths again. So we take them out of the container because they were sorted by length there, and then I glued them down onto the template. This is the completed turnout assembly resting on the wood ties. This is just a fit test. And then I used Pliobond to glue the turnout assembly down onto the wood ties. That is a contact cement, so you apply it to the underside of the rail and also to the ties. You then press the turnout down and then weight it. You can let it dry overnight, or you can use a soldering iron to accelerate the curing process of the adhesive. And once it was cured, I removed the turnout from the support board and I gave it another cleanup. The turnout is now finished, so a little bit of review from the last video segment as to what I've done. The first thing I did was to add some styrene shims on the underside of the PC board ties. This was to make them the same height as the wood ties. I then glued a fresh template onto the support board, glued all the wood ties in place, and then I used Pliobond to glue the turnout down onto the wood ties. This is basically a contact cement. You put it onto the ties on the underside of the rail. You let it almost dry and then press the two together, and then I heat up the rail with my soldering iron to activate the cement and finish the bond. One thing I should point out here is that there is one area where you do not want to use cement, and that is on these point rails, which of course have to move back and forth. So at each step of this turnout assembly, you want to make sure that these are free to move. So with the wood ties installed, this is now complete, and my attention now turns to manufacturing some sections of straight track to adjoin the turnout, because we're going to need to operate a locomotive through this turnout via each route back and forth for the purpose of the qualifications for the civil certificate. Now, to demonstrate the operability of the turnout, I needed 3 sections of adjoining straight track so that a locomotive can traverse all routes completely through the turnout. So these had to be long enough to accommodate a locomotive at each end of the turnout. So here you see PC ties going down onto paper templates for straight track. After prepping and gluing the PC ties to the template, the first rail was soldered into place. So here I'm using a straight edge to line that up, and also a weight to keep the rail in place. And then the second rail was soldered in place, and I'm using the trifecta gauges for accurate positioning of the rail so that we have good track gauge all the way along the straight track. So here's the first section of straight track assembled with both rails in place. And this is all 3 sections assembled with both rails in place. After that, I laid new templates, and then I glued down the wood ties, and these are for the 3 straight sections. I sanded the tops of those so that the track assembly would sit flush on top. And then after applying Pliobond to the tops of the ties and the underside of the rails, I added the track to the ties, and then I used a soldering iron to accelerate the curing of the glue and to lock the track down. I then weighted it while the adhesive completes its curing process. So here we see the 3 track sections for the turnout with wood ties now fixed in place. And this is after they've been removed from the template and after they've been cleaned up with a wire brush. At this point, I've got the track sections complete. You can see them at the bottom of the photograph here, and it was time to assemble a project board for this particular project. This was assembled from 1/2-inch MDF. The project board measures 2 feet long by 6 inches wide. And I think you can just see there that the track outline has been placed on the board, ready to locate the track work. I glued down foam track bed from Woodland Scenics, and that was glued down using the Woodland Scenics foam tack glue. I then marked and drilled holes for the feeder wires and also for the throw wire for the turnout. And then I cleaned out those holes with round files. And then it was time to prepare and install the feeder wires. For these, I used 22 gauge solid wire. The red and black ones are for the left and right rails, and then the green one is for the frog. So here you see me soldering the feeder wires to the underside of the rails. The way I do this is I make a little L bend in the, or right angle bend in the wire, and then I put that across the base of the rail, and then that gives me a nice contact point to solder the feeder to the rail. Here we see the feeder wires attached to all track sections, so each track section has a red and black wire, and then the turnout has a green wire attached to the frog. At this point, the track sections can be glued down with Woodland Scenics foam tack glue, and as I glue them down, of course, I'm feeding the feeder wires down through their holes. Here you see all of the track sections glued down with feeder wires underneath, and there are rail joiners at those gaps joining the straight track to the turnout. Now, to actuate the turnouts, I decided to try these linear motors that several of my friends are using. These are available online, and they basically have a back and forth motion as opposed to a servo, which has almost a sort of a rocking motion back and forth. So I did want to try these. You see the center one there is disassembled, and that's necessary to set the distance of the throw, depending on what scale you're using. You can also see a terminal block on the side for attaching the various wires, and then that red assembly is the carriage for the throw wire. And these can use, in this case I'm using 32 thou wire. So there's a little pin at the end of that assembly inside, and these can be set for a throw distance of 3, 6, or 9 millimeters. So I am going with the shortest option for end scale, which is 3 millimeters. So a pair of pliers comes in handy for pulling out that pin and putting it in the correct hole. Here you see the 3 motors after the carriage has been centered and the throw wire has been clamped in place. So one of these is for my turnout and the other 2 are for the crossover. Here you see the motor installed under the turnout, and the throw wire has been engaged in the throw bar. And the nice thing about this is that you can feed the wire up into the throw bar and then adjust the height up or down, so you've got the height correct at the track, and then you can simply cut off the excess at the bottom. You can also make micro adjustments back and forth with the carriage if you're not quite centered the way you want to be. This is a wiring diagram for the linear motors that I drew. So you can see there are 2 wires going from the track bus to the toggle switch that we need to actuate the linear motor with. And then there's 2 wires coming from the linear motor over to the motor. And then you can also see that there is a wire going to the frog. And then there's an option for 2 more wires from the motor to the track bus that will allow the motor to control the polarity of the frog, which I ended up doing. Here you see me preparing the toggle switches with leads to the motors. So we've soldered wires to the underside of the toggles. And I had a Lamicoid panel prepared to accommodate the toggle switch for the turnout. That was then mounted to the front of the project board. And of course we drilled a hole for the toggle switch so that the wires can go through. And this photograph shows the completion of the wiring for the linear motors and also the toggle switch. Now those linear motors run on 12-volt power, so I ran wires to the end of the project board and then connected them to a jack, and that is so that I could connect a 12-volt power supply. And then it was time to test the linear motor with a toggle switch to make sure it worked. Here you can see me testing the toggle switch to actuate the turnout back and forth. I used 14 gauge stranded wire for the track bus wires, and here this photograph shows the track bus wiring complete with connections to the feeder wires and also into the linear motors for the frog polarity control. The track bus was brought out to a terminal block at the end of the project board for connection to a DCC system. And here we see a test run through both routes with a locomotive under its own power. This is one of the requirements for the certificate and something that needs to be demonstrated at the time of judging. This is a test run through the turnout with a locomotive under its own power. First along the straight route through the turnout. And then back again. And then we throw the turnout to the diverging route. And then we test the locomotive through the diverging route. And then back again. So we will need to demonstrate this test at the time of merit judging. I finished off the project with stop blocks at the ends of each track. Those are just push pins. And finally a label on the front of the project board. So this is now complete and it's ready for merit judging. Thank you for watching. I hope to upload additional videos as I work my way through the various requirements for the NMRA's civil and electrical certificates. Bye for now.